So hello everyone, welcome back to our channel Tech Talks, and if you are new to our channel, please subscribe our channel for more updates. So moving forward in our DSA series, we are going to discuss today binary search. What is binary search? Binary search is a searching algorithm that is more efficient than linear search if you have sorted array. Okay, so let's take an example. So here we are given an array of length 1 2 3 4 5 6 6. Okay, and a key. We have to search whether the key is present in this or not. First approach is a very brute force approach, that linear search. We'll go to every index of the array and we'll check whether the element is equal to key or not. If equal, then return that index, or not, then return -1. Okay, this is the algorithm. This will take O of n time. Okay, so we have some of the efficient solution for that, that is binary search. We can apply binary search because our array is sorted, so we can do it in log n time complexity. Let's discuss the logic behind the binary search. Okay, so this is the array given to us. Since the array is sorted, we will take three pointers. Let This is the array 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, length of 7. Okay, we will take a start and we will point this to the initialize this to first index of array. We'll take an end variable and we will point this to this. Okay, and every time we will find mid element. So what will the mid element? If 7, then 7 by 2. What will the mid element? 7 by 2 means 3. The third is 0 1 2 3. Here is mid element. Okay, since our array is sorted, we will check the mid element is, if mid element is equal to key, then we'll return simply the mid element. Otherwise, if two possibility, if not equal, if equal, then we'll return the mid element. If not equal, then we'll check which condition, whether mid element is greater than key. If mid element is greater than key, means our key is less than mid element. So our answer will be somehow here, because every element is sorted, so the smaller element will be here. If mid is greater, then the smaller element will be here. So we will update our end variable to here. Let me change the color. End variable to here. Now our end variable is here. Now we will check. We will calculate the mid. Now what will the mid? This is 0 1 2. So our start is 0. Start plus end by 2. Okay, 2 by 2 is 1. So mid will be here. We will check if our mid element is our answer or key matches to the key, we will return this. Okay, after that, if not, then we will, if my mid is less than my key, means key is greater. Key is greater means the element will be present at the right hand side of the mid element, means somewhat here. We will check, we will update the start pointer to mid plus 1. Mean start pointer will point to this only. Okay, so what will the mid pointer now? Mid pointer will be start is also 2, mid is also 2 by 2. So 2 plus 2 by 2 is equal to 2 only. 4 by 2 is 2. So we will check whether this is equal to our key or not. If equal, then return true, else return -1, or return this index if present. I know this is a messy, but hope you understand. I am going to write the pseudocode for it. So pseudocode for this will be, we will initialize a start variable. Start is equal to 0th index, which is initially pointing to the 0th index. Then end variable, which is n minus 1th index. Since n is the length of array and array follows 0 based indexing, so we are taking n minus 1 and we will loop it through while start is less than or equal to end. Means we have not crossed the limits. Like if this is array, so we have this start is coming from this, end is coming from this. If both the pointer crosses each other, means end will be here and start will be here, means this is an invalid case. We have traversed through the whole array but we haven't find our answer. That's why it's an invalid case, so we'll come out of the loop and return -1. That's why I have taken this start is less than is equal to end. So let me delete this. Okay, so this is the pseudocode. Every time we will calculate the mid, find mid. Okay, now I will compare mid. There will be three cases: first, second, third. First case is mid double is equal to key, means mid is equal to key. We have found that mid double is equal to key. Okay, means mid is the key only, so we return true and return the mid value. Second case, if not equal, then what will happen? Mid is greater than key. Okay, so we have to check in the left side. Mid is greater and key is smaller. So a smaller value will be on the left hand side of the mid. So we will check in the left hand side. If this is array and this is mid and the mid is greater and the key is smaller, so we have to check in this. No need to check in this. We will save the time for checking in this part. So we'll check in the left hand side. Else what happened if mid is less than key? Means mid is less than key. What is the meaning here? If this is my array and mid is smaller, means our answer somewhat on the right hand side of the mid. Means here are the greater element than mid, because this is sorted in ascending order, so we know the greater element will be here. So why to check here, why to waste time here? So we'll check in this. So we will update the start pointer. So in this case, if mid is greater than key, we will update our end pointer, because we have to check in the left hand side. If here, in this case, we will update our start pointer, because initially start pointer is was here. So we have to update it, because I have to check in this portion, not in this portion. So I have eliminated this portion. So what will the time complexity of this? Let's discuss the time complexity. It's very important how it's coming log n time complexity. So I'll show you, I'll prove you how it's coming log n. Okay, let me clear this. Okay. Since every time we are decreasing our value to n by 2, so in the first iteration, what will the value? N. Okay. Second iteration, what will be the value? N by 2. Since we are reducing these things, we are eliminating the half part or half portion. Third iteration, it will be n by 2 by 2, means n by 4. Fourth iteration, n by 2 by 2 यानी कि n by 6. Okay, so we can write it as like coming to that 1. At the end we are left with the only one element. Okay, so we can observe it. It's, can we write it as n by 2 to the power 0, n by 2 to the power 1, n by 2 to the power 2, n by 2 to the power 3, like that, n by 2 to the power some value k. So n by 2 to the power some value k is equal to 1. So let me write it. So we are left with n by 2 to the power k is equal to 1. So we can cross multiply it. We will find n is equal to 2 to the power k. So if we remember the log property, what log property say? If we have a is equal to b to the power x, so we can write it as x is equal to log a base b. Okay. Similarly, it's a log property. Similarly, we can write it as k is equal to log n base 2. So we have proved it that k is log n. That's why our time complexity is log of n. We are not traversing to the length equal to the length of array. That's why our time complexity is log n. We are dividing our problem into half part, half. Then we are done with this log and time complexity. I know the video is long, but it's very important to understand the time complexity because it can be frequently asked in the company's interview. So you have to justify how it's going to be log n log n like this. So you have to have the knowledge of time complexity. So let's code it out. Okay. So we will start with this. We will make a function for that. Public, sorry, yes, I think caps lock is on. Public static void main, sorry, not main, and it will be of type int. It will return int type, and we will give it this name binary search. Okay, we'll pass our array as an argument and also key. We have to check whether key is present in our array or not, and prerequisite is array is sorted. Array should be sorted. This is the pre-requirement. Okay, so firstly let's initialize two variables, that is start is equal to 0 and it will be the last index, that will be arr dot length. This will be the length of the array and -1. Why -1? You know that array uh, follow 0 base index. Now we'll check condition while start is less than or is equal to n. Start should be less than or equal to n. Then we will find mid. How we can find mid? Start plus end and by 2. This is the mid. Now we'll check if our mid is the array, mid value is the key, mid is equal to key, then it's the best case. If mid arr of mid, sorry, mid is the index, returning the index is equal to key, then we will simply return mid. Okay, else if not equal, then if our mid is greater than arr of, sorry, arr of mid is greater than our key, means our element which is on the mid value of the array is greater, our key is smaller, so we have to check in the left hand side. So we have to update the end variable. So we will update end is equal to mid -1. Okay, else means our array of mid, that element at the mid value is less than the key, means key is greater, so our uh, answer will be somewhat the right hand side. So we will update the start variable to mid plus 1. Okay, that will be this code. And if the loop has successfully iterated through the loop, I have gone through the loop but haven't reached any of these conditions, that means our key is not present in this array. So I'll simply return -1. That is, our array is not present in this. And I will simply call it here system dot out dot println, and we'll check element is present at, and I will write the index. I will call for binary search, and I will pass that array and our key value. Okay, let me run this code if any error or working fine. Yeah, it's working fine. Let me check if the element is present at the first index or not. So our key is 8 and the array is this. Yes, 0th index and the first index. So it's working fine. Our key is present at the first index. So what we have observed, if the array is sorted, so we don't have to visit all the elements of the array. We have to check just whether our key is mid. We have to take a mid pointer and we have to relative check. What is the position? What is the current position of our key with respect to the mid? If mid is greater, then our key is smaller. It means that key is smaller. The key is smaller, then we have to check in the left hand side. And if the key is larger and our mid is smaller, then we have to check in the right hand side. And if the mid is the only key, then we have to return the mid. Simple. So this is the binary search code for binary search. What will the time complexity? As I have discussed in the details, the time complexity will be O of log n. And what will be the space complexity? Since I am not taking any extra space more than 2 variables, so space complexity will be constant. See, if you think that I have taken this variable and this variable, so it should increase the space complexity. No, it take constant space complexity, and in big O notation, if it's taking constant, then we will represent it as O of 1. Thank you. This is all about the binary search. If you have any doubt, do comment it, and we will continue with the next question. Thank you.